Welcome everyone to quick public service announcement. Hang, stall, halt and catch fire your Linux kernel with this simple trick. And the trick is, as I had to rediscover myself, simply tmpfs here in the Linux kernel. And you might wonder, wait a second, how to deadlock, halt and catch fire your freaking state-of-the-art Unix kernel from user space, like kind of sort of user space as root. Even Oracle has a warning about this. More to that later. I knew that since 20 years, nearly 18 years. Since in T2 we implemented building our source distribution here in tmpfs. And even there it carries a warning this can hang your system if you don't have enough memory. And it happened a couple of times when we implemented this 20 years ago, 19 years ago. For example, on my previous video, UltraSpark 270 megahertz with probably 128 megabyte of memory or 256 or something. And with that little memory, of course, back in the day, code was not as big and compilers smaller and so on. It didn't happen immediately, but it happened sometimes. And I had to rediscover that, and 20 years later, I also sometimes forget a little bit. And with this Ryzen overkill build here, previous video, now rocking a 5950X with 96 gigs of memory, and you can never have enough of all of those threads and memory. Need a threadripper urgently, obviously. And I wondered why sometimes overnight or heavy use my system would hang, deadlock, right? Your keyboard mouse doesn't work anymore. Even freaking secure shell doesn't work anymore. And it only came yesterday. I already suspected, obviously kernel bug, right? With all the stuff I usually fix and debug here on this channel, there must be something. Was even wondering, but it can't be so broken, right? Maybe even some AMD CPU like Intel Spectre Melt or previously AMD TLB bugs. Maybe even some crazy hardware bug like the Dragonfly BSD people at times uncovered. And then it came just me the other day, right? I didn't even pay that much attention. It's certainly not convenient, right? It's exactly why I left Windows 20 years ago, 1996-ish, for like instability, right? It's a little bit annoying and inconvenient if your system hard locks every 2 or 3 days of my excessively epic thread ripping use here. But I didn't really investigate it that much. But then just yesterday, during the other live streams on the More Live channel, it came to me, wait a second, because I was thinking memory, very high load, building LVM for all the architectures and stuff. Like, it should out of memory call, right? What would I expect? First of all, I would expect out of memory killing, like GCC using too much memory and stuff. And I was always wondering, it should obviously freaking out of memory kill the stuff away, right? And then it hit me, right? Like tmpfs obviously do, right? So tmpfs in the Linux kernel nowadays since a decade or 15 years mounted to /temp. Also other operating systems have this eventually. And tmpfs, this is a huge rewrite since Linux, whatever that was, 2.4 or something, if not 2.6. And so tmpfs obviously keeps all the files temporary in virtual memory, as the name implies. And tmpfs is also using the internal caches, and growth is also a big benefit. Previously, like Linux 2.2 or 2.0, whenever, we didn't have this, right? There was only RAMFS, like similar to an Amiga, and so on, or even probably freaking DOS. And that would emulate in hard drive as you wouldn't run a file system on that. So you would have def RAM or something and mkfs that and mount that. The drawback of that is you have lots of overhead for a file system and you have a fixed size. So the benefit that tmpfs puts everything in using the internal kernel caches and grows and shrinks as you use it. And is even able to be swapped out. Probably allegedly, and the maximum size limit you can supply with mount options Yeah, compared to RAMFS, it has of course many benefits, way more lightweight, faster, flexible, dynamically resizing. And yeah, so a little bit to my surprise, it is also, I looked it up this morning, you would expect this in file system tmpfs, but it's not living there, crazy enough. It is directly YOLO'd into memory management, shared mem here, the file we have open here, shared mem. I don't find this good style, right? So I have multiple thoughts on that, recurring theme here, critical thinking, and otherwise advocating for microkernel. So what I do not, also apparently, also, I know this file is older, yeah, 2004, so memory management stuff older, also transmitter, right, because Linus Torvalds worked at the time. This stuff should be like, I don't know, 2004 or something. So even that is old. So multiple issues with that. First of all, I'm not entirely impressed with YOLOing that into memory management, shared memory. I mean, despite microkernel having that in user space and yada yada yada. But even for monolithic kernel, I would expect this in file system tmpfs and being some separate implementation and not like YOLOed into shared memory. Because what I mean with YOLOed is you only live one and just glue it in here. And because modularity, maintainability, and so on, debuggability and boundaries of implementation features, they YOLO'd, of course I understand why they YOLO'd it in here, because performance, right? Performance, and the most performance, and you can only replace performance with more performance. If you would separate this out, of course, it wouldn't as easily be able to use all the direct shared memory data structures, and potentially be a percent or two slower or stuff. The other thing I'm not entirely impressed is that the Linux kernel deadlocks, right? So these are the same people I'm dreaming for a long time, since over 10 years. I think the microkernel is even yes, performance is less, maybe 10% less performance depending on your implementation, but I think for stability and maintainability this has huge benefits and should be used more and not less. But even then, the Linux kernel people tell microkernel people, your microkernel sucks because your drivers in user space, first of all, slower, right? Always, it's slower, so it sucks, which I don't really agree with. I rather have a more stable and more secure system and 10% slower or even 20. We have Epic and Threadripper, right? And nowadays we have slower with Spectre and Melton anyway. But even that aside, those Linus Torvalds and its gang and friends and family, they tell the world their monolithic kernel is superior because the kernel needs to rule it all and needs to be topless and DMAs all your secure shell, SSH and keys and passwords away. With that, I would argue, well, on Linux kernel, you can anyway usually physically map memory unless you have a very restricted configuration. Plus, in a monolithic kernel, it's even worse because you need to trust your drivers even more, because in a microkernel, sure, in a microkernel, most of the drivers should normally not crash your system. And if they do, they would also on a monolithic kernel. Plus, they need to try really hard to DMA and crash something. And nowadays we have an IO MMU anyway to potentially run those GPU drivers and stuff in a memory management IO scenario. But so they say microkernel sucks because your user space drivers could do whatever. Well, not only can you load your kernel modules into Linux kernel and do all this stuff anyway, and microkernel has the benefits of at least off by ones and other crash and stuff doesn't crash your entire system. But in the monolithic Linux kernel, you can just crash and hang your system with overcommitting temp, right? So in my opinion, this is a little bit dishonest argument of we need total control. The Linux kernel needs to shield all bugs and implementation details and crash and I mean, of course, security and stuff is of course important and so on. And I would even argue with the microkernel you have more security for so many reasons. But they can't tell us, hey, we need full control like over the GPU driver But I also want full control over the GPU driver, obviously open source and so on. But the Linux kernel needs to take all the details into account, and you should not be able to crash something and stuff. And yet they allow you to overcommit tmpfs, like mounting that with a high value of memory, and then you can just deadlock your kernel. I mean, either you tell us the Linux kernel need to protect us from all of it, but then you can't deadlock our kernel as easily as even Oracle with their broken Linux wants. Why is here a Solaris operating system? Wait a second, why is this not Linux? I thought this is Linux. Why is there a Solaris operating system version 10.14? Anyway, sounds, I only realized this now. So sounds PSA Solaris might be affected too, according to this Oracle post. tmpfs directory by default is a mount point, tmpfs yada yada, of course memory-based files, that means writing files to tmpfs will result in an increased use of virtual memory. Yeah, no kidding, Watson. Therefore, it will compete with user processes needing for memory. Thus, potential writing big files or many small files could cause performance problems, or in some cases cause a system to become unresponsive as if we're running out of memory. So like, yeah, so even you have it there on Solaris, and even Oracle warns about this. So in my opinion, there are two major things with that, which even I forgot. The two major things are recurring shoutout here. I said it so many times, and although I for 20 freaking years, I'm sort of Linux kernel, kind of sort of Linux distribution expert, to call myself like that. Even I forgot this, because you cannot, also after 20 years, I think they advanced so much that you can't deadlock and catch and hang your kernel as easily as this. You would think after 20 years there's some advancement and stability and stuff, but no, it's still in mm.c and all over the place. But recurring theme, the Linux kernel wasted even 20 years later, wastes even in 2021 so much of my time of not freaking printing proper error messages, right? The same with the X2 APIC I the other weekend spent my whole weekend with. And the same with that, right? If the freaking kernel wouldn't deadlock it's dead like a stone, right? You can't, in my case, and this is crazy, right? The stuff should just fail with out of memory and out of memory kill stuff, and at least freaking print a message, and certainly not deadlock as much as not even keyboard and mouse doesn't work anymore, let alone secure shell. Freaking error messages, right? If there would be at least in the system log after boot there was nothing in the system log. At least, even if it deadlocks and catches fire, halt and catches fire, at least in the log, but no, not even in the log. I would even expect never to lose interactivity with my system, either keyboard and mouse or secure shell, but yeah, whatever. But at least some freaking message somewhere that for months I was wondering, why is there some instability? Is it my self-built Ryzen thing or whatever? Error messages, right? Error freaking, or in general, diagnostics. Proper, recurring pro tip, freaking proper diagnostic and error messages. That freaking users and developers have a freaking clue and idea what's going on. And the second thing is, in my opinion, in 2021, certainly already in 2010 already, but certainly now in this day and age, the Linux kernel should not deadlock, halt and catch fire that easily. In my opinion, this should be reworked. Maybe either also not YOLO here into shared memory.c. But even if it stays in there, it should be made so with the argument of the Linux kernel should never crash and you shouldn't with reasonable means. And this is super easy, right? Just mount it and DD some data in there, right? It's not like freaking physically memory poking there somewhere through def memo. So this should not, the Linux kernel should not allow this, right? I would want my stuff to fail with out of space, like some GCC, some linker, create some file, builds LVM, all the stuff I currently do here for my Linux distribution. Freaking fail with out of space. Is it so difficult? Yeah, I mean, obviously it's difficult, otherwise I would have done. I understand it's a little bit difficult, YOLO into there with shared memory stuff, they intertwine it and intermix it, which also I would not have done that like that. But Yeah, this is the state of IT, right? Recurring theme. Yet another example of after 20 years in the industry why I'm a little bit disappointed of the state of IT, or getting a little bit depressed of why stuff is still not yet as amazing. Yeah, the stuff should fail with out of memory. Even I would even go as far as if the freaking Linux kernel, I would even rather, if it's not easily fixable, like failing instantly with out of memory. And by the way, I would even out of memory have killed all my other processes away. Like I would rather have GCC, LLVM, Clang, and LD, everything killed away, that I get some freaking diagnostics that I'm running out of virtual memory address space here, then halting, deadlocking, and catching fire my system. And I would even go as far as I would rather lose data in temp, because it is just, I mean, temp, right? Temp data. I would even go as far as I would, if that is not easy due to the shared memory intertwining, I don't even have time and motivation to look into this. Here I rather writing microkernel than spending my time with this old-fashioned C code here. But if that is not easy for all the intertwined mix whatever reasons, I would even go as far as I would rather lose my tmpfs data and like just free some memory, even randomly. Losing your temp data randomly would still be, it's not an amazing solution. The most preferable solution would be logging that, so that someone has a clue what's going on, returning no space or something, out of memory killing some processes. And if all of this is too difficult for a monolithic Linux kernel in 2021, then I would at last resort even prefer to randomly losing data, some own inodes, just free some inodes there somewhere in devtemp. I don't even care randomly, the next free page easily reachable. Of course, with a diagnostics that I know, hey, tmpfs out of memory, I'm freeing some pages, because maybe even make it a mount option, maybe or preferably enabled by default, like Deadlock on out of memory or something. So in 2021, they still fiddle and tweak with the out of memory kill mechanism, but you can deadlock your Linux kernel with tmpfs that easily. What does it mean for me? For me, it means this is too annoying for me, obviously. And it only happens, of course, with my excessive epic thread wrapping use case of building now 25 freaking cross-compiling architectures. For me, it means I will rewrite, maybe even now, you probably want to join there on the More Live channel, where we do all the live work. I will probably rewrite this, because this problem is accelerated by the fact that we have multiple tmpfs here. We mount them by default with 16 gig, which I have 96. The problem only occurs when I build, obviously failsafe, 16 gigs should be enough for everyone. Because I have multiple, right? I built them like 4, 6, maybe 8 architectures in parallel, and then we have LLVM, Clang, and multiple of those building at a time. So we have maybe 6 times 16 gigs. And of course, they're all not filled. Like if you build core utils, of course, they only use like maybe 100 megabyte or 50 megabyte. And so not all of them consume 16 gigs of memory. But what I will do, because this is way too error prone for me, I don't want to have, again, preferable would be to patch the Linux kernel, but I patch already enough. Also, I get headache when I already see this YOLO C code there. I will rather rewrite our T2 build system stuff, and I will change this, maybe now, there, More Live channel, to only mount one, so not mount multiple for each package build. But I will probably rewrite this option to build in /temp instead of mounting new source trees. So that at least you can control this better, so that you can like specify here, yo, I want now also no cursor, because it is okay, editing, whatever. You have 96 gigs of memory, so like, yeah, let's say like 64 gigs of memory should be enough for that, so that my whole system doesn't crash, halt, and catch fire, right? And only, sure, if at some point randomly 4 times, 6 times LVM builds with LTO of Firefox and stuff, then sure, some Firefox build might eventually fail if I don't have enough swap and stuff. but I rather take some build failure of Firefox didn't build because out of memory than obviously losing local interactive access or remote shell access to my system. Anyway, I hope you learned something a little bit longer with a little bit of story, 20 minutes. I hope you learned something and what crazy stuff can still happen in 2021. You would think that all this stuff is so matured, so well thought out that we are done with such trivial, really, trivial issues that we even need to talk about this in this day and age. And where my disappointment with still, like, yeah, obviously also Solaris. I mean, not that I would use Solaris, but even Linux comes with. So yeah, if you want to see me work on this shellcode refactoring that, there is a small left channel. Otherwise, don't forget to share, like, and subscribe. And I hope you learned something. And to see you next time for all the next videos and live streams to come.